Welcome to the Spintangle. This is a platform where various NEET and joint entrance aspirants as well as higher class students at advanced physics they are studying will also be helpful for these contents. You peoples are familiar with the topic probability, and we are going to start statistical mechanics first. It is a branch of physics in which we deals with probabilistic approach in physics. So let's start. What is probability? Probability is a mathematical formulation which deals with uncertain events. Say, if you are going to toss a coin, you do not know before tossing that what will be the outcome. It may be head or it may be tail. Or another system, taking another system. This is a dice. You have played Ludo. I think you all have played Ludo, in which we do not know anything about which face will appear after throwing this dice. It may be 1, it may be 2, it may be 6, it may be 5. We do not know about the event. So we have to take these formulations for the systems like this. And also we can call what is the possibility of rain today. What is the possibility today? Weather is bad, but we do not know whether there will be a rain or not in the night. So probability, it is likely to rain today. We can say it is likely to rain today. Even in the weather report, it is been reported as 90% of chance of precipitation. That means that can rain. There is a chance of 90%. Not surely this is 100%. No one can tell whether it will rain or not. Whenever we toss a coin, we do not know whether it will be head or tail. There is a equally likely probability of getting head or tail, or what will be the in case of dice, So probability, let us write first the definition. What is the definition of probability? Definition of probability. Probability is the numerical measurement. Let me write. Probability is the numerical measurement of the degree of certainty of occurrence of an event. This is what we call probability. That the degree of certainty, here we can see that the term degree of certainty. We are not sure that how much certain the event will be. Therefore, we add an extra term called degree of certainty. We do not know completely about the certainty. Okay. Let us write first let me tell you one thing, that we'll cover probability in maximum two lectures, in which will be helpful for CSIR NET, SET, IIT JAM JEST, and various advanced exams for BSc honors students or MSc students. Okay, now let us write the principle of counting. First point, we need to know about the principle of counting. What is principle of counting? We need to know about how to add probability. Addition rule. First of all, we need to know about addition rule, that probability is added and when it is added. First of all, we need to write it. Let me change the color first. If event A can happen in m ways, I will elaborate it. Please wait for a while. Let me write it first. And another event B can happen in n ways, then either event A or B can happen in m plus n ways. This is the principle of addition or addition rule, whatever it is. Okay, let me give an example. Make a systematic note, please, and join our Telegram channel, the Spintangle. Okay. Question, an example. Take it as a question. Okay. In how many ways can a number be chosen from 1 to 25 such that it is a multiple of it is a multiple of 3 or 4. Okay, this is the question. First read it carefully. In how many ways can a number be chosen? We have to choose a number from 1 to 25, such that it is a multiple of 3 or 4. Now we need to extract the multiples of 3 or 4. Here two events we will encounter. Event A, choosing a number which is a multiple of 3, and even B is multiple of 4. Even B, choosing a number which is a multiple of 4. Okay, now we can see there are how many numbers. Let me write 1 to 25 first. 1 2 3 4 5 6 7 8 9 10 11 12 13, 14, 15, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, it's a heavy work. We are very lazy peoples. We have to skip this, but for you I have to write these numbers. Okay, let me choose event A. What is event A? Event A is, we need to find the multiple of 3 from these numbers, multiple of 3s. First of all, 3 is also a multiple of 3. It is 3, 6, 9, 12, 15, 18, 21, 24. These are the numbers. Okay, let me write it first. Okay, let me write it. Multiple of 3s. Multiple of 3. 3, 6, 9, 12, 15, 18, 21, 24. Okay, these are the numbers. How many numbers? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 numbers which are multiple of 3. Now we have to choose another hard work to do. This is too much hard task for lazy people like us. Okay. Okay. Let me mark with them with green color. Okay, one second. Multiple of 4. There are this one is also multiple. This one is 4. Then 8. Then 12. 12 is also a multiple of 3 and 4 both. Then 16, 20, and 24 is also. Okay, let me write them. 4, 8, 12, 16, 20, 24. There are 6 number. I think 6 number. Okay, there are 6 numbers which are multiple of 4. Okay, then we can say what was the question first. The question was, okay, wait for a while. What is the question? In how many ways can a number be chosen from 1 to 25 such that it is a multiple of 3 or 4? Okay, we have got these. In the definition you can say there is a number m. What is m? Event A can happen in m ways and event B can happen in n ways. Then the total number of ways m plus n. Okay, then either A, we can write the answer as either A or B can happen in 8 plus 6. This means this one is m, this one is n. You can relate with the definition first. There is 14 ways. This is the answer. Let me remind you one thing. The definition says that either A or B. You need to follow what is said, either A or B, and then you need to add them up. Okay, do not rush into adding them. First of all, you need to see what is the language of the question. If the language of the question said that either A or B or something like this, then either or relation. If there is either or relation, then you can add. Okay. Just wait for a while. 1 second. Okay, this one is addition rule. Next, multiplication rule. Okay, heading multiplication rule. Multiplication rule. Okay. If event A happens in m ways, again there is m ways, we can take A in m ways and B in n ways, B in n ways, another event B, you can write it in your copy. Okay, then therefore A and B can happen in m into n ways. This is the definition, this is the basic definition. You can write it in your own language. I am here to clear your concept only. Okay, take another question or example, whatever it is. What is the total number of possible outcomes when a pair of coins are tossed together? What is the total number of possible outcomes? What is the total number of possible outcomes when a pair of coins, a pair of coin. Okay, there are two coins. Okay, these two coins are being tossed first. For event A, write down event A in the similar way that previous question we have discussed. In the same way, you can write event A. Define event A. That event A. What is event A? Tossing first coin. Tossing first coin. Event B. What is event B? Tossing second coin. Okay. Event A has. Let me take that this is related to event A. This is coin A or event A. Whatever it is. This is event A. This is event B. Event A has two possible outcomes. What are the outcomes? Head and tail. Therefore the ways, two ways, either head will come or tail will come. Okay, there are no extra possibilities. If you toss a coin, then there will be two possibilities, either head will come or tail will come. Okay, even B is similar, even B, because even B is related to the second coin. Even B has two possible outcomes. My handwriting is getting poor day by day. Sorry for this mistake. You can write it in your own style or in your own copy as you wish. Even B has two possible outcomes. One is head and another is tail. Okay. Let me remove the round shapes. Okay. Head and tail. Okay. There is also two ways. Okay. That means A and B are tossed together. If A and B tossed together, A and B, there is a AND relation between them. There is a AND relation between them, that they are being tossed simultaneously. They are being tossed, A and B. If there is AND, then you can add, you can multiply M and N like this. Here M is what? M is 2. These two is M, and these two is N. Then 2 cross 2 is equals to 4 ways. In tossing a coin A, tossing 2 coin A and B simultaneously, we get 4 ways. What are the 4 ways? Let us check. Fact check. Let us check. Two coins. There can be head in the first head in the first coin, head in the second coin, head in the first coin, tail in the second coin. Write them first. 2, 1, 2. Okay. This one is the this one is the first coin. This one is the second coin. Okay. Then tail, head may come in the first coin, tail, second coin, head, and then tail come. There are 4 ways. You can see them. There are 4 coins. Okay. These are the coins. These are the ways. This is one way. This is one way. This is one way, and this is one way. Okay. Okay. These are the 4 ways. You do not need to elaborate them like this. You need the formula. There is a AND relation between them, and you make them multiplied by each other. Okay. Then this is okay, principle of counting. That was addition rule, multiplication rule. Okay. Next is, what is next? Next is, let me write first permutation. What we mean by permutation? Permutation. Let me write the definition first, and then I will elaborate it. It is an arrangement of a set of objects in some definite order. That, and also there is a condition. Repetition not allowed. I'll make it clear. Repetition not allowed. Okay. There is a rule. There is 2 rule. I think so. There is 2 rule. Okay. Rule 1. 1 or 2, 3 rule. It can have 3 rules, 4 rules. Okay. Let me write it first. Rule 1. Indistinct objects can be arranged in n factorial ways. Okay. Distinct objects, they have to be distinct. Okay. They have to be distinct. Example. Suppose we have a box. Okay. Let me take another example. Consider arranging 4 English letters. Suppose P, Q, R, and A's. We can arrange them as 4 factorial ways. How many ways? 4 factorial ways. As I have written it, n factorial ways, there are n distinct objects. Here 4 distinct objects, P, Q, R and S, and we can arrange them in 4 factorial distinct ways. Okay, 4 factorial distinct ways. 4 factorial means 4 times 3 times 2 times 1. 4 3 is 12, 24 ways. Okay, let us check. Let's check. Okay, I have to write a long thing. So P, Q, R, S. This is a way. P, R, Q, S. R, P, Q, S. S, P, R, Q. 24 ways I have to write them. Okay, let us take another example. You can arrange them like this. You can arrange, these are the distinct ways. I have taken a large number of ways, 24 ways I have to take. Okay, let us take another example. Let us take another example that consider arranging three letters P, Q, R. They can be arranged in 3 factorial ways, as there is 3 letters. There are 3 letters. Okay, there is a number of ways we can arrange is 3 factorial. 3 factorial means 3 times 2 times 1 equal to 6 ways. Okay, this is correct. This is fine. This is fine. Okay, 6 ways. What are the 6 ways? Let me write PQR is the first way. PQR. Okay, then PRQ. This one the second. Then RPQ. Then RQP. Then QRP, and another is QPR. You cannot arrange them different than these ways. Okay, you cannot arrange them. They will be repeated. If you can arrange, they will be repeated. As I have told you one thing in the definition. In the definition, I have told you repetition not allowed. Repetition not allowed. Okay. Repetition not allowed means you cannot arrange them as this. You cannot write P, Q, Q. This is not allowed. This is not allowed. Okay. Or R, R, R. This is another way, but not allowed. Not allowed in permutations. Okay. Okay. This is the rule 1, rule 2. Okay, let me write rule 2. You can make systematic notes, or you can join the Telegram group. I will give the class notes. These class notes I can make them PDF and will send it to Telegram. Okay. Rule 2. Rule 2. The number of permutations of n distinct objects taken are at a time. Here also repetition not allowed. Repetition not allowed. Okay. The number of permutations of n distinct objects taken are at a time. Okay. Then there are n distinct objects. You can take r at a time. Okay. You have say you have 7 candies, and you have to select You have to choose any 3 candies from them. Okay, no repetition allowed. You can choose distinct candies. Okay, then this will be the ways. NPR, these are the ways. NPR ways. NPR, what is NPR? This is n factorial upon n minus r factorial. Is it clear? Please comment below on the comment box. Okay, yes. Let me clear it with a example. I do not tell anything without example. In how many ways can a grocery keeper displays 7 different soaps, 7 different soaps, okay, in 3 different boxes. Okay, you have 7 different soaps. Okay, 7 different soaps. Say 7 colors. There are 7 colors there. Okay, and you have 3 different boxes. 3 different boxes. 1, 2, 3. You have to keep them in these boxes. In how many ways you can keep them? Okay, you have 7 different soaps. Say the soap named A, B, C, D, E, F, G. 1, 2, 3, 4, 5, 6, 7. Okay, 7 soaps named as A, B, C, D, E, F, G, and these are the boxes. And these are the boxes. You have to. You can place A here, B here, C here. You can place in another way that you can place C here, D here, E here. In how many ways? We are not doing these broad extension of this model. We can directly obtain this from the formula I have written above. Okay, so how many ways? NPR ways. NPR ways means here n is equals to 7, r is equals to 3. Okay, then how many ways? There are ways. You can write ways as this omega symbol. Okay, ways. We will not be able to write with the term ways frequently. Okay, you can write this symbol as ways. Okay, how many ways? NPR. This means 7p3. 7p3. This means 7 factorial by 7 minus 3 factorial. Okay, how much is this? Omega is equals to 7 into 6 into 5 into 4 into 3 into 2 into 1 by 4 into 3 into 2 into 1. This is 4. This is 4 factorial. This is 4 factorial. Okay. 4 4 3 3 2 2 1 1. Okay. 7 into 6 into 5. How much is this? 210 ways. Okay. This is a large number of ways. You can arrange them. Okay. This is the NPR. This is the NPR formula. Okay, this one is the rule 2, that permutation of n distinct objects taken r at a time. Okay. Rule 3. Rule 3. The number of permutations of n objects in which n1 sorry, let me correct it, in which n1 are of one kind n2 are of second kind and n3 are of third kind. This will be the number of permutations will be that number of ways will be, in this case will be n factorial, the total number factorial, the distinct factorials, n1 factorial, n2 factorial, n3 factorial. Okay, isn't it? Okay, this one is the rule 4 of permutation. Okay, let me give an example of rule 3 for permutations. In how many ways? A question. In how many ways alphabet, let me check one thing. Alphabet 1 2 3 4 5 6 7 8. Okay, in how many ways 8 letters of alphabet can be arranged in a row, okay. First let us write the word alphabet. Okay, alphabet. How many letters are there? There are 8 letters. Okay, 1 2 3 4 5 6 7 8. I have counted it earlier. Okay, you know it. Okay, let us check one thing, that there are 2 A's. There are 2 A's. How many A's? Okay, there are 2 A's. One A, this one is 1A, another A is this, 2 A's, 2A. Okay, this means n1 is equals to 2. Again, this is a single. Okay, L 1L, there is one L, n2 is equals to 1, there is 1 P. P is how many P? n3 is equals to P. Sorry, n3 is equals to 1. This one is 3. Then H is equals to H. How many H are there? 1 H. n4 is equals to 1. Okay, there are so many letters. B, how many B? How many B? 1 B. Okay, n5 is equals to 1. How many E? n6 equals to 1. How many T? There is n7 is equals to 1. Okay, 1 T there is. Only one thing is repeating is the A. Okay, let me remind you the formula first. Okay, what was the formula? Omega is equals to n factorial upon n1 factorial, n2 factorial, n3 factorial. You can write the formula as dot 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 dot. whatever, how many letters are there in the sentence, how many distinct ways. Okay, this formula can extend up to whatever you need. Okay, and n factorial means how many n factorial. What is n? This 8 letter, this 8 is n. N factorial means 8 factorial. N1 factorial means 2 factorial, then 1 factorial, this n2 factorial. N3 factorial means 1 factorial, n4 factorial means 1 factorial, n5 factorial means 1 factorial, n6 factorial means 1 factorial, n7 factorial means n1 factorial. Okay, this means 8 factorial upon 2 factorial, easily 1 factorial means 1 factorial means 1. Okay, and you need to know about one thing, that 0 factorial is also equals to 1. Why this is 1? I will surely cover this topic. Okay, I will surely cover this topic. 8 factorial means 8 times 7 times 6 times 5 times 4 times 2 times 1 upon 2 times 1. Okay, 2. Okay, let me calculate it. 56 times 56 times 30 times 4, 56 times 120, 56 times 120, how many? 56. Okay, you can calculate this. This will be 5600 plus 20 means 1 1 2 0. This means how many? I can calculate it in my calculator, but okay, 6720 ways. There are how many ways? 6720 ways. Okay, this is a huge number of ways you can. What are the ways? I cannot give you any example of this. I can give one thing, alphabet. Okay, this is a outcome. This is a way you can write. You can write L first. Alphabet. This is quite bizarre. And PAL, alphabet. Okay, and so on. You can arrange them in 6720 ways. Okay, this is a huge way. This is a huge number of ways. Okay, this is up to 6720 ways. Okay. Comment one thing, that if the word was given mammal, arrange. How many ways that you can arrange the letters? How many ways? Okay, write it down on the comment box, please. If you are watching this video, write it down on the comment box, that how many ways that you can arrange the letters of the word mammal. Okay, then the last topic of today's lecture is combination. Okay, combination. We have did permutation first, then combination. Let me write the definition first. It is an arrangement of a set of objects where order is not important. Where order is not important. Rule. What is the rule of combination? The number of permutations okay, not this is not permutation, the number of combinations of n distinct objects taken are at a time are at a time regardless of the order. The order is not important here in case of combination. Okay, it is an arrangement of a set of objects where order is not important. The rule, this is one rule, there are one rule. The number of combinations of n distinct objects taken are at a time regardless of the order. You can disobey the order. Okay, this is number of ways in case of this NCR. I think you are familiar with NCR. It is useful tool for binomial distribution. I think you have learned it in class 12. I think. If you don't know, I am telling you one thing, that omega is equal to NCR means n factorial upon n minus r factorial and r factorial. Okay, this is combination. This is the formula of combination. Let me take one example. I am nothing without examples. Okay. How many triangles can be formed by joining three vertices of a regular pentagon? How many triangles can be formed by joining three vertices of a regular pentagon? First of all, I will draw a pentagon. Let me check one thing, that is there any, oh no, okay, this is pentagon. Okay, let me label them with A, B, C, D, E. Okay, here you need to see one word, that regardless of the order. I have told one thing, that regardless of the order. Wait for a while. Regardless of the order. Here it is. Order is not important, or where order is not important. Okay, you can see one thing, that what is AEB triangle? AEB triangle, it is same as BEA triangle. Okay, and it is same as ABE triangle. This means these triangles are the same triangles. You do not need to calculate them individually. Okay, AEB, BE, ABA. That's why it is mentioned that order is not important here. Okay, so there are how many vertices? Number of vertices. Okay, let me change the ink. How many vertices are there? There are 5 vertices. What are vertices? You know, these are called vertices. Okay, In Bengali it is called Shirsho Bindu. Okay, 5 vertices. Then n is equals to what? N is equals to 5. And in making a triangle, how many vertices are needed? There are 3 vertices needed to make a triangle. Okay, because we know a triangle has 3 vertices, only 3 vertices. That means 5 vertices, and R is what? R is equals to 3 for triangle. Okay, this means how many ways that will be, how many triangles that you can form from 5 vertices? That will be 5C3, that this 3 for triangle. Okay, and this 5 for this pentagon. If it was hexagon, then you can take 6 for this is for hexagon. Okay, 5C3 means 5 factorial upon 5 minus 3 factorial and 3 factorial. Calculate it. It is a easy calculation, I think. 5 into 4 into 3 into 2 into 1 upon 2 factorial, 2 into 1 into 3 into 2 into 1. Okay, 3 into 2 into 1, cross them and multiply. There is 10 ways. Okay, 10 ways, I think 10 ways. Okay, this means you can make distinct 10 distinct, here is distinct 10 triangles. Ways means here distinct 10 triangles you can make. You can make this triangle as the triangle I have mentioned in green color. The triangle I have mentioned it in the green color. Okay, one second. One second. This is the triangle. This is one triangle. You can make another triangle like this. You can make another triangle like this. You can make another triangle like this, and so on and so on. You can make total 10 distinct triangle. Okay, these are the direct triangles. Okay, let me show one triangle which is not direct. You can make this triangle also. You can make this triangle also. Okay, you can make this triangle also. Okay, this triangle also. Okay, check it. Please check it on your copy. Please check it. Okay, that's fine. Today's lecture is over. I think this will be enough for your first. Please digest them, and please comment below that what should be done in the next lectures. I will surely cover what let me write one thing, that I will cover the statistical mechanics. First I will cover the statistical mechanics, and that's why I have started probability first. And the probability is the base, the probability first. Okay, it will take 2 classes to cover full probability, and then we will solve problems, and then we'll jump into the probabilistic approach, which is called random walk. The very much interesting fact, this is random walk is like a drunk person which is who is standing on a road, and it can take different paths. Okay, we'll discuss it later. Okay, fine. Okay, yes, goodbye, have a nice day.